now going to be looking at, we've done one step, which are mole ratio, that are mole to mole. We've done two-step ones that are mole to something or something to moles. So you would do one conversion, 2 moles, and then you do mole ratio somewhere in there. These ones are going to have 3 steps. Some may be 4 if you want to do the dm cubed conversion with it, which I'm going to show you a quick step for that. You're going to change it to moles. Then you're going to be able to use the mole ratio to switch substances. And then you have to change it to something else. So that's why it's going to take 3 steps. Now, of course, I also threw in some balancing here. So as you go along, you have to make sure you balance your reaction correctly before you continue on. Another thing to point out here is in this worksheet, they do say decimeters cubed. So I'm going to point this out to you right here. 1 decimeter cubed is equal to 1 liter. So if you have decimeter cubes, essentially you still have liters. So keep that in mind. Now they could give you milliliters. That would give you an extra step because you'd have to change it to liters. They could give you kilograms where you have to change it to grams. But for the most part, these ones are going to take you 3 steps in order to finish. So without further ado, I'm going to go ahead and just balance the first one. Okay, you guys can check and make sure I'm doing it correctly. And then we will begin. So a 2 goes there and a 2 goes there. These ones obviously would be 1 and 1. Okay? Does everything add up? Okay, now we're getting quicker with the balancing. We can kind of do it in our head. That's good. Okay? So, but before you begin, you must have a balanced reaction or you can't do a mole ratio step because you don't have coefficients. Okay? So, now we got to figure out what are we starting with and which way are we working it to. So it says, how many grams of silver chloride? So silver chloride is one that I want. Are produced when 45 grams of calcium chloride react. Okay? So we're looking at starting with calcium chloride, so 45 grams of that stuff. And we want to convert it over here to our silver chloride. Now they add on this little extra part to confuse you, but do realize it says with excess silver nitrate. Excess means there's just lots of extra of it, and it's not something you need to worry about. So that excess part is just extra added information that you don't really have to do anything with. Okay? So if I'm following my general T-chart setup, what goes in the upper left corner? The 45 grams of CaCl2. You need your unit, the gram, and you need your substance, which would be the calcium chloride. And make sure you keep those 2 things together now. Because we are going to switch substances, because we're going to work it to silver chloride. So now, I can't switch substances yet because I'm not in the mole. So I have to do grams to moles. And where do I find my interchange for moles for grams? Look at the periodic table. Add up the molar mass. Exactly right. So I'm going to diagonal down my grams of CaCl2. And I'm going to go to 1 mole of CaCl2. So now I go and I look up my molar mass. What's calcium's mass again? 40.08. What's chlorine again? 35.45. Make sure you multiply that by 2 because there's 2 of them. So what does our molar mass end up being? Guys, you're supposed to be calculating your molar mass. Yes. It is correct, 110.98.
Settle down and stay focused, please, people.
Yes.
Not the first time you've heard thunder.
It's not like this.
Knock it off.
Come on. Now, we are to the mole. Guess what? When we're in moles now, we can go to the mole ratio and switch substances. Since we're now at the mole, we can go ahead and switch. So, what do I diagonal down? Moles of calcium chloride. What am I going to? Moles of silver chloride. Now what do I look at?
You put the 1 in the diagonal down.
Yes, I look up here at my balanced reaction. I look for the coefficients. So the 1 goes next to the CaCl2, right? Down here. The 2 goes next to the silver chloride on the top. Okay, you insert your coefficients. Now, this would be good if we could stop here at the mole, but does it want moles of silver chloride? Nah, it wants grams of silver chloride. So we've got to do one more step. Okay, we're going to do one more step. We're going to diagonal down moles of silver chloride. Okay, and we're going to go to grams of silver chloride. So, what is the molar mass of silver chloride? Because silver is a pretty heavy atom.
107.9.
Well, we're going for hundredths here.
87.
87, good. We're rounding to 2 decimal places, remember? Plus our chlorine, 107.87, plus 35.45. That gives us our total molar mass, which is 143.32. Now we can calculate. And if you look, your things are supposed to cancel appropriately. The grams are supposed to cancel with the grams of calcium chloride. If they're on the diagonal, they will cancel. Your moles of calcium chloride will cancel with the moles of calcium chloride on the bottom. The moles of silver chloride should cancel with the moles of silver chloride on the bottom. So what are we left with? The only thing left is now our grams of silver chloride, which is what we want. So we multiply the top and we divide by 110.98 on the bottom. And we end up with our amount. And what is our amount? 116.22 is the calculator answer, so we need to round it to sig fig answer, and that would be how many digits?
2.
2. So we only get to keep 2. So we're going to keep this first one. What are we going to do to the second one? And then we're going to have to put what in that spot? The filler 0. Don't forget the filler 0 there. And don't forget your unit and your substance in your final answer. Yes? Well, when anything is on top and bottom, they like divide out. So if I have grams of calcium chloride on the top and grams of calcium chloride on the bottom, they cancel each other out. So they like divide. It's like 5 over 5 would give you 1. So it's like the same idea there. Okay? So we end up canceling them out, and that's how we're converting, is to get to that very end, is we're going to keep putting in these conversion factors, and then they cancel, so we end up with the one stuff that we want at the end. Okay? So that's one particular one where this one, we would call it a mass to mass, because you're starting with grams, you're ending with grams. First step is to change it to moles. So this here you would change to moles. Can't do anything till you're in the mole, because you can't switch compounds till you're in the mole. The second step, we call it the mole ratio step. Mole ratio step is where you switch compounds. Switch substances. And then last but not least, we're going to, at the very end here, change it back to grams. So that's our 3 steps. First step, change to mole. Second step, mole ratio. Third step, change it to grams. Now, in other problems, though, they might want you to do liters or particles. So depending on what they ask for is what you're going to change it to. Okay? And speaking of one of those, let's do one of those where we're doing something else. So let's look at, say, number 2 is already balanced. Yes, this one is 1, 1, 1, 1. Correct. Let's look at doing, say, down here. Oh, that's molecules to molecules. Here, let's look at one on the back. Let's do number 7. Number 7's fun.
Not number 7.
Yes, number 7. Number 7's fun. First, we have to balance, though. So we need a 4 there. We need a 3 here. And we're going to need a 4 here. Okay? So we balance it. Because it gave us this one where we're starting with this decimeter cubed stuff. Decimeter cubed of hydrogen. Now, we're starting with 67.8 decimeters of hydrogen. Now, what did it say on the front about decimeters cubed? 1 decimeter cubed equals 1 liter. So essentially, we have how many liters here? 67.8 liters. So that's what I'm going to start with, my 67.8 liters of hydrogen. Okay? Now, I'm working to which other thing in the balanced reaction? Which other substance? I want atoms of iron. So, I'm going to start here, and I'm going to work it over here to my iron. That's my destination. Starting with hydrogen, I'm going to work it over to iron. Now, before I can do anything, I have to change my liters to what? Got to change it to moles. Everything goes to moles. So, liters to moles. How many liters in 1 mole? 22.4 liters at standard temperature pressure. Liters of hydrogen to moles of hydrogen. So, now I'm finally to the mole. What can I do once I'm at the mole? Mole ratio and switch to the new substance. So, I have moles of hydrogen up here. So that means I have to diagonal down those moles of hydrogen, put them on the bottom for canceling, and I want my moles of iron on the top. So this is the mole ratio step. Now where I need to look.
The
Coefficients in the balanced equation. So what's my coefficient for hydrogen? Okay. What is my coefficient for iron? 3. Good. Now, it wants atoms of iron. So what do we do with atoms? Correct. We're going to be using Avogadro's number now. Okay. So I'm going to diagonal down my 1 mole of iron, because 1 mole of iron equals how many atoms of iron? 6.02 times 10 to the 23rd atoms iron. So, now we have it set up. Is everything going to cancel? Well, let's check. Liters of hydrogen, liters of hydrogen. Moles of hydrogen, moles of hydrogen. Moles of iron, and look what I'm left with. Just atoms of iron, which is what I want. Now, how many sig figs should we keep in our final answer?
3.
3, because we start with 3. So, final answer, 1.6 or 1.366 something times 10 to the 24th. So I'm going to count my sig figs now. Keep the 1, keep the 3. What do I do to the 6?
Round it up.
Round it up. So I get 1.37 times 10 to the 24th atoms. Don't forget your unit. And Fe is our substance. Okay? So, pick another one. Any other one. We've got time to do like 2 more. 4? So let's work number 4. It's a combustion one. So what do we start balancing first? Carbon. Carbons are equal. So what comes next? H. What do I need to put in front of my water here? H2. Good. 2 times 2 gives me 4. Now let's count up our oxygens. How many in the carbon dioxide? 2. And how many in the water? 2. That's an even number. So what do I need to put here to make it have 4 as well? A 2. There you go. So we have our combustion one. Now, what volume of methane? Which one's methane up here?
CH4.
CH4. This is methane. It completely reacts with 500 liters of oxygen. So I'm starting with oxygen, and I'm trying to figure out my methane. Okay? Now let's set this up. 500 liters O2. What am I going to put on the bottom?
22.4 liters.
Correct. The 22.4 goes on the bottom. 22.4 liters equals 1 mole of O2. Correct. Now that I've done my changing to moles, what can I do? Mole ratio. Let's move on to mole ratio. So, mole ratio. I'm going to diagonal down my moles of O2. And I'm going to moles of CH4, methane. Now I insert my what?
Coefficient.
Coefficient. So, 2 moles of the oxygen, and we have 1 mole of our methane. Okay? Last step. What does it want now? Volume. So, 1 mole of methane equals how many liters again?
22.4.
22.4. This is kind of interesting. If I have 22.4 on the bottom and 22.4 on the top, what can I do to those? I can cancel them out, and I don't have to worry about calculating them.
Yep.
Yes, that's a nice little added tidbit. So basically, what does it end up being? 250 is our calculator answer. How many sig figs do we get to keep?
1.
Yes, when it's just 500, where do you start? No decimal.
Right.
Start from the right. Guess what? This one only has 1 digit. So how do I make this one have 1 digit?
300.
The 2 rounds up to a 3. Filler zeros, liters, CH4.
Wait, I need that 5 you round up.
5 rounds up, 5 and above.
What's the beginning that you told me 5 rounds down?
5 is always rounded up.
And no one told us that.
No, wait, what's the chant for it? Not the chant, the song.
The chant.
Okay?
I don't know.
I swear 5 rounded up.
We have time for one more. Anybody else like to select a problem?
Yeah.
Number 10. Okay, let's look at number 10.
Miss McGuire.
All right, number 10. How many grams of silver will be produced if 86 grams of copper are used? Well, what do we need to do first? Balance. So we need to balance. Are we balanced?
Yes.
Yes.
Good. Now, this one's a grams to grams because we have grams of silver, grams of copper. So 86 grams of copper is what I'm starting with.
Find molar mass.
Yes, find the molar mass. What's the molar mass of copper?
63.54.
63.55 grams equals 1 mole of copper. Now, I'm at moles of copper. What can I go to? Mole ratio. Mole ratio. So, we have moles of our Cu going down here, and we're going to moles of our silver. Okay, what do we look at now to put those numbers in? Coefficients. So, we have how many moles of copper? many moles of our silver? 2. Good. Now last step, because it doesn't want moles, it wants grams. We have to do one more where we get rid of our moles of our silver and we go to grams of our silver. Silver we already said was 107.87. Okay? And our final answer without sig figs, calculator answer 291.95, but how many digits do I get to keep?
2.
Only 2. So keep the 2. What do I do to the 9? Round it up or leave it? Leave it. So then what do I fill in for the 1 here? Filler 0, grams, silver. So what I'd like you to finish are these problems, and we will check them. You know, you can work on them over the break, but we'll check them on Thursday when you get back and finish your reaction rates. Work on your study guide, because we'll have like 3 classes before the test when we get back. So you don't want to let it just all go away. So make sure that you do some reviewing, okay?